Nafisa, can you do this?
No, sir.
Okay. Alia, this was the first lecture of biomolecules. Actually, we did some part in yesterday's class. So please let me know the oxidation state of silver. Here, wherever is the AZ present. Okay. Any answer? Should not take this much time for oxidation state. Okay, I'm going to explain. See, the first compound you can see is basically AgNO3. You know what this NO3 exists as? Nitrate ion AgNO3 minus. So I'm going to take this as -1. First of all, we need to calculate the oxidation state of Az. So I'm going to take X plus. What is the charge on NO3? -1. So it will be -1. Will be equal to what? 0, because there is no charge on the compound. So X will be equal to +1. Are you getting my point, everyone? So this will have an oxidation state +1. You can do it in another way, like you can consider oxidation state of every metal, every element, like AgNO3. So what is the oxidation state of Ag? We are going to calculate. So I'm going to take it as X plus. What is the oxidation state of nitrogen? Here it will be +5. Why? Because oxygen is the most electronegative element. So it will withdraw electrons from other elements here. So nitrogen has 5 electrons in its valence electron. So it will take all the 5 electrons from oxygen. We will consider it like that. Now, oxygen has 3 oxygen are there, and each will have oxidation state of -2, because oxygen is the most electronegative element, and it has 6 electrons in its valence cell. So in order to satisfy itself, it will get 2 electrons. So there will be charge 0. There is no charge on the compound, so I'm going to put it 0. So X plus 5 minus 6 is equal to 0. So X minus 1 will be equal to 0. So basically X is equal to +1. So from the both method, you can say you can see that this Ag has +1 charge. Now, when you talk about this Ag2O, you can see we are going to calculate the oxidation state of Ag. So I'm going to consider the oxidation state of one AgH X. So there are 2 Ags, so 2X plus what is the oxidation state of this O? So it will be -2 will be equal to 0. So 2X is equal to +2. So X will be equal to +1. Now you can see this is Ag plus. If there is mono ions, whether it is monoanion or monocations, the charge present will be equal to the oxidation state. So it shows that it has oxidation state +1. Now, when you are going to talk about this AgNH3 whole twice OH, so I'm going to explain this AgNH3 whole twice OH. We need to calculate the oxidation state of Ag, so I'm going to take it X. NH3 has oxidation state that is 0, and 2 is there, so multiplied by 2. And this OH is what? -1 hydroxide ion, so it will have -1 will be equal to, there is no charge on the compound, so it will be equal to 0. Now you can see x minus 1 is equal to 0. So x will be equal to 0 plus 1. So you can see basically in tolerance reagent, the oxidation state of Ag, silver, is plus 1. Is that clear to everyone?
Yes, sir.
Can I change the slide? Please do reply everyone. Thank you, Sneha. What about you,
No, sir.
Ali?
I'm still writing the last part.
Okay, okay. Please write it. I was asking about everyone got it. Yes, I'm going to scroll it up for Alia. This is it, right, Alia? Yeah. Please write it, Alia. Done. Okay. Everyone done with this? Sneha? Nafisa?
Yes.
Okay, thank you. What about you, Hamza? Hamza, are you done with this? Alia and Sneha, please do respond. Okay. Okay, Alia, you are going to take a screenshot from here and let me know whenever you are done with this. This was the first lecture of biomolecules and then this carbohydrates. So what is carbohydrates? Initially, scientists defined it like hydrates of carbon. It's called carbohydrates, and whatever fit in this formula is carbohydrate. CHS2O whole H2O whole Y. So after some times, it was found that some compounds that satisfy this formula are not carbohydrates, like ethanoic acid, or you can call it acetic acid. So acetic acid has a formula which we can write this like this, and it satisfies this formula but is not carbohydrate. And there are some carbohydrates that doesn't satisfy. There are some compounds that doesn't satisfy this formula but are carbohydrates. So that's why this formula fails and this theory fails, hydrates of carbon. Did you take a screenshot? Alia. Okay. So please take this screenshot from here also. Rhamnose. Rhamnose is a carbohydrate that doesn't fit in that general formula, but is a carbohydrate. Please take a screenshot of this. And carbohydrates later defined as a compound that contains ketonic, either ketonic group or aldehyde groups with polyhydroxy. Hydroxy, that means OH4. Okay, very good, Ali. Now take a screenshot of this. There's some it's just definition, you will get it. Carbohydrates that are sweet in taste are called sugar. Most common sugar that is used in our household, that is called sucrose, and that the sugar present in milk, that is called lactose. Now come to classification point. Classification based on hydrolysis. So it will be monosaccharide, oligosaccharide, and polysaccharide. Oligosaccharide that cannot be further hydrolyzed, like glucose, fructose, and lactose. And oligosaccharide on hydrolysis, it will give 2 to 10 units of carbohydrates that are called oligosaccharides. 2 to 10 units. You can also say like 2 units, that means disaccharide, 3 units trisaccharide, 4 units tetra, penta, like this. Are you done with this, Alia? Please do respond. Okay, thank you. Now there is polysaccharides. Polysaccharide, that means gives a lot, several units of carbohydrates that are called polysaccharides. Its example is a starch cellulose, glycogen, and gums. And these are generally these are not sweet in taste. That's why they are called non-sugars. So please take a screenshot of this also, and let me know. Very good. Now the other classification is based on reducing and non-reducing sugar. So what is reducing sugar? The carbohydrates which will reduce. Basically, not like this. Reducing sugar that reduces tolerance reagent, Felling's reagent, and Benedict's reagents. And non-sugar are called basically non-reducing are the carbohydrates which does not reduce this tolerance reagent, Felling's reagent, and Benedict's reagent. So please take a screenshot. Example, I wrote it. Reducing sugar like glucose, fructose, and galactose, disaccharide, maltose, lactose, etc. And this glucose, fructose, and non-reducing sucrose. Very good. And then comes tolerance reagent. Now we are going to talk about tolerance reagent. You all are done with this. Very good. Now see what happens when you are going to use this. So carbohydrates, if you are going to put this ammonical silver nitrate or tolerance reagent in carbohydrates, this carbohydrates oxidizes. Carbohydrates oxidizes, and this Ag plus will be reduced. Ag plus will be converted into Ag. That is also known as silver meal. Silver meal. PPT. It will be PPT. Precipitate. Now the question is that Ag plus has a oxidation state plus, and Ag now when it is in elemental form, molecular form, it will have oxidation state 0. It will have oxidation state 0. So you can see from +1 to 0. From +1 to 0, that means it gains 1 electron. That means reduction takes place. Now carbohydrates contain aldehyde, either aldehyde or ketonic group. Aldehyde or ketonic group, keto group. So it will be oxidizes into COO minus. It will be oxidizes into COO minus, or you can say carboxylic acid. In alcohol chapter, you will learn when alcohol oxidizes, it will oxidize into aldehyde first and then carboxylic acid. Also, when ketone oxidizes, basically, if secondary alcohol oxidizes, it will form ketone. And then if it will oxidizes with a strong oxidizing agent, it will be converted into carboxylic acid. Okay. So please write it. This is how it takes place. Carbohydrates oxidizes and this silver reduces. So basically that's why the sugar which reduces Ag is called reducing sugar. Are you getting my point? Nafisa, Sneha, and Alia.
Yes, sir.
Very good. Let me know when you are done with this. It's a very easy chapter, but you have to focus on the chapter. There will be some. This chapter is all about remembering. If you will go after carbohydrates, there will be vitamins. You need to learn that names. Are you done with this? Done. Very good, Alia. Sneha.
Yes, sir.
Nafisa.
Finished.
Okay. Thank you. Now see. The next reducing agent is Fallings reducing agent. Fallings reagent. Now, what does this Fallings reagent? Basically, we have two container in which we call it. Wait a minute. We call it Falling A and Falling B. We have two containers, Falling A and Falling B. What is this Falling A? Falling A basically contains aqueous CuSO4. Aqueous CuSO4. So when water present in copper sulfate, it will be copper sulfate dot 5H2O, which is known as blue vitriol. Which is known as blue vitriol. It reacts with water to form crystallization. There will be crystallization of water, CuSO4 dot 5H2O. And Falling B, that means we write it as NaKT. And this is known as basically Rossel salt. This is known as Rossel salt. So we also call it NaKT is a common name like sodium potassium tartrate. T is for tartrate. Sodium potassium tartrate. Also, it has a chemical formula. I'm going to write it. Basically, CH3. Wait a minute, not CH3. COONA, COONA, and then CHOH, and then CHOH, and then COO. This is known as Rossel salt, sodium potassium tartrate. So what happens when you are going to, first of all, they will be mixed together and then carbohydrates will be mixed. So when the carbohydrates will be mixed in this, carbohydrate will be oxidized. There will be oxidation state of carbohydrates in the same way as in what was the first name, Collins reagent. In the same way as in Collins reagent, there will be oxidation. And as you know that carbohydrates contains aldehyde or ketonic group, so it will be oxidized and form COO minus. Again, there will be Cu. This Cu has an oxidation state of +2. So this Cu +2 will be reduced and form Cu copper matte. And there will be brown PPT that will show. There will be brown PPT, reddish brown. That will show it is reduced. So please write it.
Yes, sir.
Finished. So basically there is mixture of aqueous CuSO4 with sodium potassium tartrate, and then you are going to mix carbohydrates in this. So if the carbohydrate contains aldehyde, this will be oxidized into COO minus, or keto will be oxidized in the same, and this Cu +2 will be reduced. So this is called Fallings reagent. Is everyone done with this? Very good. Hamza, why are you not responding today?
Yes, sir.
Okay, very good. Moving to the next reducing agent. The next is basically Benedict's. Benedict's is same as Benedict's is same as the next Phalanx. Benedict's is same as Phalanx. So you can see what is this Benedict's, same as Phalanx. I'm going to write as same as Phalanx. Phalanx reagent. So basically what happens here? So there is also mixture of mixture of aqueous CuSO4 plus there is another container in which you are going to mix it. It's sodium nitrate. It's sodium citrate. Sodium citrate, citrate, you can call it citrate. And this has a chemical formula CH2COONA, and then CHO, and then CH2COO, CH2COONA. Now you can see what happens here. This aqueous CuSO4 will be converted into CuSO4.5H2O, that is called blue vitriol. Now you know that this will have a oxidation state of +2. So this carbohydrates, again, this is very easy. Carbohydrate will be oxidized. There will be oxidation of carbohydrates, and it will be converted into in the same of COO minus, and Cu+2 will be reduced and form Cu and show brown PPT, reddish brown PPT, reddish brown PPT. So there is reduction of Cu+2 and there is oxidation of this. And you know that this carbohydrates either contain aldehyde group or ketone. And this is called blue vitriol. So this is also a test. Please do right. And you will see the mechanism in aldehyde and ketones.
Sir, what is that?
Let me
Sodium.
know. Citrate.
Sir, what's the okay.
What do you want to ask?
No, sir, just that.
Visa. Okay. It's common name of this compound. Again, it's happening. It's so embarrassing. Everyone done with this? Am I audible to all of you?
Yes, sir.
Okay, please do write it. Okay, thank you.
Sir, your screen is still loading for me.
Oh, can everyone see my screen?
Yes, sir, we can see.
Okay. Very good. Wait a minute. So, am I audible clearly, right?
Yes, sir.
Okay. Now, see, the next part is basically also on class third classification. Classification based on number of carbon atoms, based on number of classification based on number of carbon atoms. So basically, I'm going to write the name, number of carbon atoms, number of carbons. If aldehyde present in the carbohydrate, what will be the name of it? And if ketone is present, what will be the name of it? So if the number of carbon atoms, carbon is 3, then the name will be aldotriose, aldotriose. And if ketone group is there, so it will be ketotriose. Again, if the number of carbon is 4 in the carbohydrate and the functional group that present in carbohydrate is aldehyde, the name will be aldotetrose. Are you getting my point? Aldo will be there for
Yes, sir.
aldehyde and tetra stand for 4. So tetrose. And its name will be, please let me know, ketotrose, right?
Yes, sir.
Okay. So please name this 5 and 6. Please write it. Ketotrose, it will be
Sir, you're lagging.
aldose. Am I lagging now? Wait a minute. Am I lagging now, Nafisa?
No, sir.
Let my video be on. I thought. Hmm. Please do the name. Very good, Alia. Very good. Everyone done with this? What is the name of this fifth rose? What will be the name of this aldohexose? What will be the name for keto? It will be ketopentose at the last, and it will be ketohexose. Yes or no?
Yes, sir.
Please write it. Please make me know. Wait a minute. Am I audible now? Hamza, you are the host. Please make me host.
Okay, sir. Done.
Thank you. Am I audible now clearly?
Yes, sir.
So everyone done with this?
Yes, sir.
Okay. Thank you very much. Now it won't be disturbed. Inshallah. See. After this, there is three classification. The first one was, you can see, on the basis of hydrolysis. The second classification was reducing and non-reducing sugar. And the third classification was on the basis of number of carbon atoms. Okay. Now see, we are going to start MOP, that stand for methods of preparation. MOP of glucose. What does this MOP means? I will take this name only for preparation in organic chemistry. Methods of preparation of glucose. Okay. Now see, please focus here. It's very important. In the previous class, I have already discussed about dextrorotatory and levorotatory. Is everyone aware of that? Dextrorotatory and very good. That is optical activity part, optical activity. Now see, the first method of preparation is from sucrose. From the first was from sucrose. And sucrose has a chemical formula. Sucrose has a that is C12H22O11. This has a formula. Now, when you are going to hydrolyze this sucrose, hydrolysis take place, H3O positive. So what happens here? It will be converted or dissociated into two products. The first one is glucose and the second one is fructose. And now you know what glucose has a chemical formula, that is C6H12O6, and fructose has also chemical formula C6H12O6. And what is the difference between this glucose and fructose is that this glucose has aldo group and this fructose has keto group. This glucose has aldo group and this fructose has keto group. Are you getting my point?
Yes, sir.
Now see, this is where so this is how we are going to prepare. This is how we just prepare glucose. So sucrose is, oh wait a minute. I just wrote the reaction in wrong way. Just wait a minute, please. Let me correct this. Oh, very good. Just move this to here. Okay. Now this is our sucrose, and sucrose has a chemical formula C12H22O11 from sucrose. So when you are going to hydrolyze it, it will be converted into glucose and fructose. And hey, this is how we just covered this aldo, and then here it is keto. Please write it and let me know. And both of you know this is monosaccharide and this is also monosaccharide. Yes or no?
Yes, sir.
Please write it. Then we will talk about optical activity part.
Yes, sir. Finish.
Everyone done with this? Very good. Very good. Now see, we are going to talk about the optical activity part. First of all, this sugar is dextrorotatory. Dextrorotatory. That means D, and D has a positive. That means clockwise. Are you getting my point?
Yes, sir.
And now this glucose is also dextrorotatory. That means plus D, and it has a rotation of, let's say, 52, and this is levorotatory. This is levorotatory. uh, Learnivio is the host now. Wait a minute. Okay. Rotatory, that means negative, and L. You know that levo has anti-clockwise and dextro has clockwise rotation. And you know what the degree of rotation in fructose is? 92. That means minus 92, and this is plus 52. So if you are going to see the net rotation, it will be in negative. It will be in negative. That means levo. Are you getting my point? If you are going to see the net rotation plus 52 minus 92, it will be minus 40. The net rotation will be in anti-clockwise. Yes or no? Nafisa,
Yes, sir. Yes, sir.
everyone getting my point? So the net rotation is plus, basically negative, and initially it is dextrorotatory, and the net rotation after reaction or after the product is L. That means it is inversion of this. Initially it was in clockwise, and finally the net rotation was in anti-clockwise. That means it is inversion, opposite. Please do respond, everyone, not only Nafisa. Hamza Sekhani,
Yes, sir.
Sneha. So are you getting my point, Sneha and Alia? So the enzyme used here is known as also invertase. Invertase. Because inversion takes place, that's why this its name is invertase. And due to this net rotation, you can see initially it is in only clockwise, but after this you can see the net rotation is in anti-clockwise. That's why this is also known as inversion of cane sugar. Inversion of cane sugar. Is that clear, everyone? Please do write it and let me know when you are done with this. Then we will talk about glucose. This is the first method to prepare glucose, and that is from sucrose. So what we just did, just hydrolyze the sucrose, we will get glucose along with fructose, but we concentrate on glucose because we are doing MOP of glucose.
Sir, can you scroll down a little bit?
There is nothing, I think. You want this?
Yes, sir. Okay.
Okay. Please let me know, everyone. So was there any test in the last class or in the previous week?
Like yesterday?
No, not yesterday, like in the last week.
Yes, sir. There was test.
Okay, thank you. I just forgot that. So I was asking for in the coming week on Saturday, can we have class from 6 p.m. because we couldn't complete our 1.5 hours last class. Can we do that? If everyone is
Yes,
okay with
sir.
that,
Yes, sir.
Hamza, Sneha,
What,
6
sir?
to 8. Can we have class on incoming Saturday on 6 p.m., 6 to 8 p.m.?
Sir, I have another class.
Okay, then let it be. Let it be. Let me
Sir,
know
what
when
is
every
about inversion of cane sugar?
inversion of cane sugar. That means basically this sucrose is cane sugar. You can say
Yes, sir.
sucrose. That means sugar, and it just what happens there. It was the clockwise and net rotation on the right side. That means product side is anti-clockwise. So it just inverted. It is inverted. It is
Yes,
inversion.
sir.
So inversion, we just wrote inversion of cane sugar. That means cane sugar initially was in clockwise, and finally after production it is in anti-clockwise. So inversion of cane sugar, or you can write inversion of sucrose also. Sucrose.
Yes, sir. Okay.
Everyone done with this?
Yes, sir.
Thank you. Okay. Can I move to the next slide, Hamza?
What, sir?
I was just changing the slide, so I was asking for the.
Yes, done.
Okay. Now the next method is from starch. This is starch from starch. Starch is also a carbohydrate. So see how we are going to prepare glucose from starch. Starch has a chemical formula C6H10O5 whole N. This is the chemical formula of starch. And when you are going to hydrolyze this H3O positive, that this is hydrolysis. So what happens here? You can see there will be NC6H12O6. There will be formation of glucose. Glucose has a compound aldehyde group. So I'm going to write it aldo. Okay. So this is how we are going to prepare glucose. The reaction is very easy. From a start, you need to just hydrolyze it. You will get your answer. Is that clear?
Yes, sir.
Okay. Please do it. And initially, in the previous preparation, you saw that I wrote glucose as dextrorotatory. That means it is in clockwise rotation. Okay. So we already discussed about the chiral and the chiral, right? In previous chapter, hello
Yes, sir.
alkanes and hello arenes. So if anyone have any doubt about chiral, this is the time to ask. Everyone done with this?
Yes, sir. Finish.
Okay. Now see. Now we are going to learn about the properties. What is this? Properties. Basically, properties of glucose. Since we just learned about the how to prepare methods of preparation of glucose, now we are going to learn about the properties. See, the first properties we are going to write, or we can write, glucose is also known as dextrose, is also known as dextrose. As you know that this is dextrorotatory, so you can also call it dextrose, is also known as dextrose. The next point is very important, and it is about a structure of glucose. It is about a structure of glucose, and you know that it has a chemical formula C6H12O6, and its structure is CHO, and then OH on the right hand side, H on the left hand side. H on the right hand side, OH on the right hand side, sorry, left hand side. H on the right hand side, OH on the left hand side. Again, OH on the right hand side, H on the left hand side. And then again, OH on the right hand side, H on the left hand side. And at last, there is CH2H. So this is the structure of glucose. What I want from you, this is the chemical formula of glucose. Can you tell me the total number of chiral carbons. Chiral carbons. Please let me know. Can anyone tell me the chiral, how we are going to calculate chiral and all? Nafisa, do you know how to calculate chiral carbon? See how we are going to find chirality. First of all, chiral carbon. See, carbon must be sp3 hybridized. That means four single bond, and must have connected or bonded with four different groups, four different atoms, elements, or you can call it groups. So how many carbon are there? You can see carbon, this is carbon 1, carbon 2, then 3, then 4, then 5, and then 6. Total number of carbon is 6. Can anyone tell me how many chiral carbons are there? If you are unable to find it, just let me know. I will start explaining. Just don't waste time. If you don't have any idea what to do, and if you are still trying, just let me know that also.
Sir, can you explain?
Yeah, why not? So see, Nafisa, this is CHO, that means aldehyde group, and aldehyde group, in aldehyde group, you know that C double bond O will be there, and H, and then this. So if you are going to see, its hybridization will be sp2. That's why this carbon on the top carbon is not chiral. Is that clear?
Yes, sir.
Now, if you are going to see this carbon is bonded like this. This will be oh, this H. This will be OH, and it is bonded with two hydrogen. Yes or no?
Yes,
This
sir.
is OH. I just forgot to write. Okay, so you can see two groups are same. That means this carbon is also not chiral. Yes or no?
Yes, sir.
So if you are going on this carbon, you can see COH and then H and then CH2OH and then again whole different part. All of this. Okay. Are you getting my point? This OH is different. This
Yes.
CH2OH is different. This H is different. And after this vertical line is, you can see different. That means basically this is chiral carbon. Also, if you are going to see, this is OH, this is H, this is again whole below part is different than above part. This is also chiral. This is also chiral. This is also chiral. You can see. So the number of chiral carbon present in glucose in this structure is 4. Is
Yes,
this
sir.
clear to
Okay.
everyone? Can you visualize for all these 4 carbons? Because I just explained I just explained only one. So can you visualize all the 4 carbons? And if you have still any doubt, please ask me. Is everyone done with this?
Yes, sir.
What about other students? Sneha, Hamza?
Done, sir.
Very good. Alia? Hamza, you don't reply at all. Okay. Now we just learned how to do preparation. What is the methods of preparation of glucose and then properties. And now the chemical reaction will come. So, right topic, that is chemical reactions. Chemical reactions. Wait a minute. Chemical reactions of glucose. So first of all, we are going to react this or chemical properties of glucose. You can say reaction with HCN, hydrogen cyanide. Reaction with HCN. So we have to do at least 9 reaction of glucose with different reagents. So do you know how does this? As you know that aldehyde groups are there. So you have to understand how aldehyde react with hydrogen cyanide. So first of all, in glucose, there are two functional groups, aldehyde and alcohol. Alcohols does not react with HCN. First of all, I'm going to write a point about this. Alcohols. Okay, I'm going to write it here. Alcohols does not react with hydrogen cyanide, that is HCN. So only one functional group left, that is aldehyde. And aldehyde reacts with HCN. How do it reacts? Basically, ketone and aldehyde both reacts with HCN. So you know what happens. This is carbonyl compound. Carbonyl compound. Do you know what is carbonyl compound? Anyone? So any functional group in which C double bond O is present, that is called carbonyl compound. So aldehyde, ketone, carboxylic acid, ester, acid anhydride, all these groups are carbonyl compounds. Are you getting my point? Acid halide
Yes,
and
sir.
all. So see what happens when HCN reacts with this. With a minute is this is HCN. Now you know that CN is more electronegative than hydrogen, so it will have negative charge, and hydrogen has positive charge. Again, oxygen is more electronegative than carbon. So what will oxygen do? It will take electron from oxygen. That's why oxygen will have negative charge. Oxygen will have negative charge and carbon will have positive charge. Carbon will have positive charge. Now see what happens. What you need to do is just add positive to negative, negative to positive. That is nature. Positive will attracted by negative and negative will attracted by positive. Okay. So what we will get, OH and carbon will connected with CN and this will be like this. This is known as cyanohydrin. This will be known as cyanohydrin. So in this manner, reaction will take place. So first of all, write this. And if you have any doubt in this mechanism, please ask me. Then I'm going to show you the reaction of glucose with this hydrogen cyanide.
Yes, sir. Finish.
Everyone done with this? Okay. Now see. Hamza, Sneha.
Sir.
Okay. Now see, you know that how we are going to write the structure of glucose. This is CHO and OH on the right hand side, H on the left hand side. H on the right hand side, OH on the left hand side, and then OH on the right hand side, OH on the right hand side, H on the left hand side, H on the left hand side, and then CH2OH. So if you are going to react this glucose with HCN, you know that this OH, that means alcohol group, will not react with HCN. It will only react with aldehyde. So you also know that, can I write this as this? Can I write this? CHO as this? I just expand the structure of CHO. Is there any problem if I will write CHO like this?
No, sir.
Now see, whatever I just explained above, there will be negative, there will be positive, and then again it will have negative, it will have positive. Now what happened? This positive will go to this negative will go to this positive. So what we will get, C, and then there will be OH and there will be CN, and then there is H, and then the rest part is same. The rest part is same. OH, H, OH, OH, H, H, OH, H, and then CH2OH. So you already know that in this carbon, how many number of chiral carbon in this compound glucose on the left hand side? Can you tell me the number of chiral carbon? We just calculated number of chiral carbon atoms is 4. Yes or no?
Yes, sir.
So please do a favor and calculate the number of chiral carbons here. Number of chiral carbons is equal to, please do of please do this. Oh, wait a minute. Can anyone calculate this number of chiral carbons?
Sir, 5.
Yes, it will be. You can see this is not because 2 hydrogen is there. So this carbon 2,
Yes,
then
sir.
3, then 4, and now this C. Different
Yes, sir.
carbon, different group, and this different group. So this is also. So number of chiral carbon equals to 5.
Yes, sir.
Please let me know when you are finished with this.
Yes, sir. Finish.
Very good. Can I move to the next part, Hamza?
Yes, sir.
Okay. Now see, the next reaction is reaction with hydrogen iodide in the presence of red phosphorus. You know what? This is a strong oxidizing agent. This is a strong oxidizing agent. This is a strong oxidizing, sorry, not oxidizing agent. I'm so sorry. This is a strong reducing agent. Reducing agent. So see what happens. What is reducing agent? The removal of hydrogen. Removal of hydrogen is reduction or oxidation. The removal of
Oxidation.
hydrogen is oxidation. So what will happen here? There will be addition of hydrogen, yes or no? What
Yes,
will
sir.
be, yes, please do respond only. Nafisa, very good. Thank you so much for responding so well, but no one else no one is responding. Okay, frequently. Okay, so see, first of all, I'm going to explain the mechanism. So there is alcohol, ROH. So if you are going to add this hydrogen iodide in the presence of red phosphorus, what will happen here? It will break this bond and H will be added. So what will be the product? RH, that means hydrocarbon, that means alkane, and H2O will be eliminated. Are you getting my point?
Yes, sir.
That means if you are going to add this compound, this reagent in alcohol, that alcohol will be converted into alkane. Now, if you are going to add this reagent in carbonyl compound like aldehyde and ketone, so one bond will be broken, this bond will be broken, and hydrogen will be adding here and here. And another bond will be broken, and then hydrogen and hydrogen. Now you can see this is again alkane, yes or no? This is again alkane, and H2O will be eliminated, yes or no?
Yes, sir.
So it's very easy. If you have carboxylic acid, it is so much reducing agent. That means very, very strong reducing agent that even it reduces carboxylic acid to alkane. So you can see one of the bond will be broken like this, and hydrogen will be added here and here. One another bond like this, and you can see this bond will also be broken like this, H and H. Now you can see that, you can easily see that this is H2O and this is H2O will be eliminated, and what we will left with are CH and H and H. That means carboxylic acid is also converted into alkane. Even this is LiLH4. Did you hear about this? This is basically lithium aluminum hydride. Does not reduce alcohols, but HI in the presence of red phosphorus do. LiLH4 is very expensive reagent. It is also a very strong reducing agent. But this you can see it reduces alcohol to alkane, carbonyl compound, that means aldehyde ketones, to this, and this is also a carbonyl compound, carboxylic acid, to alkane. Now I am going to write the reaction for this. C double bond O H and then OH Wait a minute, please. C double bond O, H, and then OH, then H, then OH, then OH, and then H, OH, H, and there will be CH2H. So if you are going to react this with HI in the presence of red phosphorus, you can see what happens. Please concentrate here. One bond will be broken, it will be like this. Second bond will be broken, it will be like this. Now this bond will be broken, hydrogen will be here. This bond will be broken, hydrogen will be here. This bond will be broken, hydrogen will be here. Again, this bond will be broken, hydrogen will be here. Okay, now you can see this is OH. Again, this bond will be broken and hydrogen and hydrogen. Now I'm going to write this. From this carbon, you can see this carbon has CH3. Then come to this carbon, one hydrogen CH2. Now come to this carbon CH2. Now come to the another carbon CH2. Now come to the last carbon, this carbon CH2, and now CH2 and then H, this is CH3. That means this glucose is directly converted into 1, 2, 3, 4, 5, 6 and hexane. That means hexane. Is that clear to everyone?
Yes, sir.
Please do write it.
Yes, sir. Finish.
Very good. Everyone run with this.
Yes, sir.
Okay, I'm going to the next part of the reaction. The next part is basically the third chemical properties. Reaction with NH2OH. Reaction with NH2OH. So see, how does this NH2OH, this is known as basically hydroxylamine. Hydroxylamine. So you can see C double bond O, then this. Reacting with NH2OH, it does not react with alcohol. So you can see like this. And what you need to do is just remove, oh, wait a minute, just remove water. NH2H, I am going to write NH2H as this, H2NOH. And what you need to do is just remove this water, and there will be a product that is C double bond NOH. Connect this carbon directly to N, and this is known as oxide. This hydroxylamine does not react with alcohol. Is that clear?
Yes, sir.
Now I'm going to write the reaction again. CHO, and then OH, and then H, and then OH, and then OH, and then here CH2OH. CH2OH. So there will be H, H, OH, and H. And if you are going to react this with NH2OH, what will happen? So I'm going to explain this like this. I just wrote it here, H2NOH. And what you need to do is remove this. This is H2. Remove this water. So what you will get CH double bond NOH, and then OH, H, OH, OH. Here it will be H, H, OH, H, and then CH2OH. This is known as glucose oxide. Please write it. The reaction is very simple. Everyone done with this?
No, sir,
Sneha?
still writing.
Okay, okay. Take your time. Very good. Hamza?
Sir.
Very good.
Yes, sir, finish.
Very good. Now the next reaction, fourth reaction will be reaction with Br2 plus H2. And you know what? Br2 plus H2 is mild oxidizing agent. Mild oxidizing agent. Just focus on the reaction first. Basically, bromine water only oxidizes aldehyde to carboxylic acid. Aldehyde to carboxylic acid. It doesn't oxidize alcohol because it is mild oxidizing agent. Okay, so you can see the reaction first, then you can write CHO and then OH and then H, then OH, and then OH, then H, OH, and then H. And there will be CH2H. So if you are going to react this with bromine water, you know that only this aldehyde will be oxidizes directly into carboxylic acid, and alcohol will be as it is because it cannot oxidize alcohol because it is mild oxidizing agent. It is mild oxidizing agent, and its name is gluconic acid, or also known as aldonic acid, also known as aldonic acid. One more important point is that please write it in note whenever you write. Only oxidizing aldehyde but not ketone. In order to oxidize ketone to carboxylic acid, it have basically there will be cleavage of bond to oxidize ketone into carboxylic acid because ketone present in between two carbons. So please write it.
Yes, sir. Finish.
Very good. Everyone done with this?
Done, sir.
Very good. So I'm going to slide it down. Now see, we have the next reaction, that is reaction with concentrated HNO3. And the important point is that in this, with HNO3, aldehyde easily converted into oxidizes into carboxylic acid, and CH2OH also converted into carboxylic acid, but there is a condition. Oxidation will take place faster in aldehyde than 1 degree alcohol, then 2 degree alcohol. Basically 2 degree alcohol, it cannot oxidize, it's not gonna happen. So what is important here is that it can oxidize primary alcohol to carboxylic acid and aldehyde to carboxylic acid. It cannot oxidize secondary alcohol or tertiary alcohol. So if I'm going to ask how many secondary or tertiary, primary, secondary, tertiary alcohol present in this, can anyone answer? How many secondary, tertiary, primary, secondary, tertiary alcohol are present in this compound?
Sir, secondary.
Secondary alcohol, how many? So do you know how to calculate secondary alcohol? Do you know how to calculate secondary halide? and haloalkanes and haloarenes. So
Sir,
you need to
just see how many
carbon is connected to that carbon.
yeah. Yes.
So if you have alcohol like this, and if you have alcohol like this, and if you have alcohol like this, you can see. So in order to calculate the degree of alcohol, you have to see the degree of that carbon to which alcohol is connected. So you can see this OH is connected to this carbon and it is 2-degree carbon. So this is secondary alcohol. Are you getting my point?
Yes.
And in order to see the degree of this alcohol, you have to see the degree of this carbon. So it is 1 degree because it is connected to only one carbon. This carbon is connected to 2 carbon. That's why it is secondary carbon, and OH is directly connected to secondary carbon. That's why it is secondary alcohol. When you see this, you can see OH is connected to this carbon and this carbon is connected to 3 carbon. That's why it is 3 degree. So it will be tertiary alcohol. Is that clear?
Yes, sir.
Is that clear? Now you can see. First of all, this alcohol, see this alcohol is connected to this carbon, and this carbon is directly connected to one carbon. So it is 1 degree alcohol or primary alcohol. And if you are going to see this carbon, this alcohol, this carbon will have 2 degree because it is connected to lower carbon and this carbon. So all the other carbons which is connected to alcohol is secondary, so they cannot oxidize. So if you are going to react this with concentrated HNO3, what will happen is very easy. Aldehyde will be converted into carboxylic acid, and this is secondary alcohol, so it will be as it is because it is secondary alcohol, and concentrated HNO3 cannot oxidize secondary alcohol, and this primary alcohol will be converted into COOH. So please write it, and its name is glucaric acid. Its name is glucaric acid, or also known as basically, oh wait a minute, so or saccharic acid. Saccharic acid. Please write this. Then we have left with only sorry, 4 more reaction. In coming Sunday, we are going to complete this glucose, and then we will start cyclic structure of glucose in the next class, Saturday. Then after that, we will talk about fructose. And after writing this, you may leave the class. Thank you so much.
Yes, sir. Finish.
Okay, thank you.
Thank you, sir.
Thank you, everyone.
Thank you, sir.
Thank you so much.